In this tutorial, we'll start to explore the concept of lag. So in many ways, the idea of lag has often been demonized by many when discussing lag. What is it? Is it a value? Is it disruptive? So in essence, what we need to establish in this is really what lag is. So lag is in essence a very kind of informal way of defining what we call delay or latency. A delay between interacting systems. So the idea of really club lag or kind of club shaft lag or handle lag is really a delay between, in essence, the kind of wrist, the hand, how the club move and interact in swings. In essence, the idea of latency, the delay, the interaction, those timings between how the club moves and how the wrist moves. Often how it's been more sort of perceived more within, say, the kind of more popular definition of golf coaching is the idea of kind of increased wrist angles or wrist stretches. That's often been described as lag. But lag for more accuracy is just the time delay, the interaction, the latency between kind of how those segments, mainly the club and the hand and wrist, then move in swings. So in some ways, lag's been a bit demonized by many, often in a very playful way, very similar to say caffeine. Caffeine has been demonized by many. Caffeine is one of the very few supplements. It's actually one of only 3 supplements that actually has any real efficacy. It actually does what it's meant to do. So very much like caffeine, in light lag is often not so much the lag or the caffeine is the issue. It's more things like the dosage, the volume, the timings of are more problematic rather than, for example, actually caffeine itself, or in this case, as it would be lag in this case. In some ways also connects back to the idea of stress. So stress from a very physiological and neurological and also anatomical definition. Stress is hugely valuable, and we actually need stress across many areas to really allow those systems to evolve and develop and grow. So again, areas such as stress has been demonized. What we don't want is prolonged exposures to stress. So these kind of short bouts of stress are vital, say, for areas such as our electrical system. We are a series of electrical and chemical interactions in the human. We need these stresses to then start to challenge, for example, muscle fibers to grow, bones to become more dense, those new synapses in the brain to be formed, the idea of kind of how we then start to learn the concept of neuroplasticity, evolution, adaptation, for example. But it's when we get then excessive exposure to stress, those electrical charges, for example, through our kind of electrical system, often in essence kind of flatten the batteries, which we know when we start to kind of compress those electrical charges are simply not good for our well-being. So sometimes we look at these areas, stress, caffeine, lag. They've often been demonized by many, but they're hugely valuable when we actually understand what they're designed to do, what their rationale is, and then certainly then the important bit really, how they sit within context. So when we look at learning, for example, what's vital within learning is we look at the most influential area to improve, not always the easiest area to improve. Many people, in essence, when we look at it trying to improve how they move, will look at the easiest area. What's the easiest adjustment I can make today? But that then really is counterintuitive to stress in the system. We need to be exposed to those very small amounts of stress to allow, for example, ourselves to grow. Whereas what we need to look at more so, it's what's the most influential area to improve. So of all these things around us, which one has the most influence, which one then really allows us to grow, to evolve, to be stressed in a nice way, rather than what's the easiest one then to improve. And that then often really goes against often kind of counterintuitive thinking, being stress-free, doing something easy, okay, versus then being very stressful and very challenging. From an evolution understanding, we need to be stressed and challenged then to allow those systems to develop and grow. So let's look then once again at that definition of lag. So lag or latency really is the interaction between those kind of paired and matching segments. So lags happen in essence across every single joint in our body. For example, the foot to the ankle to tibia and fibula up to the knee to the femur, into the hip joint, the pelvis, through those segmental, almost every vertebrae through the sacrum, lumbar spine, thoracic spine, neck, each rib. We look at the rib or the rib cage as a structure. In essence, we have 12 rib cages, these 12 pairs of rings that wrap around to form the rib cage. There's a lag that happens between the interaction as we produce rotation. As we rotate through backs, and the rib cage moves kind of downwards and inwards on the lead side and then up and external on the trail side, vice versa then as you move into kind of anti-clockwise or counterclockwise rotation down through that trail side, that rib cage then moves more into internal rotation and then flexion, vice versa, external rotation and extension through that then lead side. So we have these interactions, these lags that happen across every single pair joint in the body. So when we look at the idea of kind of club lag in golf, a much more realistic way of actually establishing really how well, for example, the hand and wrist and the club move and interactions. Look at more so areas such as the idea of the kind of wrist stretch, which we've discussed in a previous tutorial, but more so look at areas such as the peak wrist stretch relative to impact. So for example, how is that wrist stretching the idea of that kind of three-dimensional stretch in that lead wrist. Lag is often referred to in that kind of colloquial definition. Whereas actually relative to, for example, then the time in the downswing. And then also what's vital when we look at, say, the idea of kind of wrist stretch is how does that then peak wrist stretch then align with the maximum angular velocity of the hand. So look at these much more kind of precise interactions. So the actual idea of wrist stretch, some people, for example, will have a very inactive amount, for example, say radial deviation through those wrists. So there's more play available. They have more usable play in those joints. Play is that very kind of playful definition. For example, say there's more range in the joints. There's more elasticity in those joints. They're moving transition. So they can produce lots of lag. So areas such as, for example, how radially deviated those wrists are in back. So when then control and influence in many ways, then one's ability to produce the idea of that wrist stretch in transition. Also then looking just at wrist ranges. So for example, the architecture, the bone structure of the joint, the tissue tolerances, the tissue elasticities, the tissue profiles. So just the shape of the wrist, the architecture, the bone structure, the tissue type will then very much control and influence then one's ability to produce that concept of lag in downswing. So when we look at lag, it's very much based on our architecture, our tissue profiles, how we move through backswing, clubbing knees, for example. However, looking then much more accurately then, it's looking at how that wrist is stretching, for example, relative to the time in the downswing, and also then areas such as then, for example, the peak angular velocity of those hands. So using a wonderful example now of a very, very established, actually a very recent PGA Tour winner, and then looking at really how that kind of player produces the concept of lag in transition, we actually then start to display those very intrinsic dynamic values on screen. So as shown by the circle on screen now, we have a wrist stretch of just over 8.5 degrees. So in essence, whatever that kind of three-dimensional, the three-dimensional net angle of that kind of lead wrist is at top of backswing, how much they increase that 3D stretch of that wrist in transition by just over 8.5 degrees. And also a value here when we start looking at a comparable example as we move through this case study, a wrist load-in. Again, the three-dimensional angle of that kind of wrist forearm shaft at the top of just under 110 degrees, once again, as shown by the circle on screen. But what becomes very valuable then is looking at then that wrist stretch. So looking at that kind of peak stretch. So when we start to then move in the downswing phase, what becomes of much more significance then is really when is that wrist stretch, or when do we then almost start to move away from that pre-stretch value? Very similar in some ways to the idea of kind of pelvis thorax stretch, the closure, the rebound, the recoil. When does that ribcage start to catch up? The idea of wrist stretch to impact is when do they then start to move away from almost the concept of almost kind of unhinging or kind of moving back in towards that kind of ulnar deviated position. So in this particular player's case, that happens at 92 milliseconds from impact. So they hold that stretch for much longer in that downswing phase. We actually then look once again at shown by the circle on the screen, the downswing time. Their whole duration of downswing is 277 milliseconds. So that stretch is actually being held until 92 milliseconds in advance of impact. So they're moving through tremendous amounts of stretch, three-dimensionally through those wrists, and actually maintaining that for just under kind of, 0.09 of a second as they're then moving into and approaching impact. However, then, when we start looking at that much more kind of global story of this concept of kind of wrist stretch, that's also happening in line with the peak angular velocity. So we look at then, say, once again, as shown by the circle on the screen, this person produces a peak angular velocity. So how fast the hands are in essence rotating on their plane around their body of 16 degrees per second, so 1,616 degrees per second. And it's also happening, once again, as shown by the circle on the screen, 20 milliseconds or 20.8 milliseconds at advance and impact. So to give some sense of scale, these are wonderfully produced values, very high hand speeds. And then looking more at the physiology, for example, the idea of that segment interaction or the kinematic sequence, the timing of when we produce those peak angular velocities. 20 milliseconds of that lead hand is almost the absolute ideal or somewhat ideal value from, say, a timing of the peak hand speed when we look at, say, the physiology of movement relative to impact. So there's a lovely interaction here. Over 8 degrees of wrist stretch in transition happening or being held for very long, just over 0.009 of a second or 92 milliseconds away from their impact position, happening with a very fast angular velocity, 1,616 degrees per second, and then that hand speed also being peaking at 20 milliseconds in advance of impact. So a wonderful interaction between then the amount of stretch, how long that stretch is held for, how it relates to the speed the hand's moving at, then relates to the time relative to impact, when we then start to almost move away from that stretch, the closure rate, the recoil in some ways, the ulnar deviation, as it could be referred to in that wrist stretch, then relative to when that hand then reaches its peak speed. However, then looking at a more recreational player, so when we look at, say, for example, the recent PGA Tour winner, then we look at a more recreational player, what can we then start to see? So, for example, you'll see here at top of backswing, we have a wrist loading value of just under 90 degrees. So they have much more, in essence, stretch in that wrist at top of backswing, which is why then we actually then see an increase, once again, as shown by the circle on screen, of 0 degrees. So there's actually no increase in that kind of wrist stretch, what's often called lag, for example, in those wrists in transition. Once again, lag isn't the kind of often what we define it as. It's simply a time delay between how those segments move in swing, rather than, for example, people actively trying to kind of manipulate and move the club that way. So when we look at lag, it's much more integrated, much more kind of intrinsic in some ways. Then we then start to look at this particular player's case. When they actually produce in that peak wrist stretch, it's actually 297 milliseconds, which is, as shown by the circle on screen, the exact same length of time as them being produced in that downswing phase. So, for example, they produce their max wrist stretch at top of backswing because there's no increase in that value in that downswing phase. So therefore, we then start to look at then the wrist angle relative to the maximum hand speed of 134 degrees per second. So, for example, when their hands are reaching their peak speed, they are a lot less almost stretched through those wrists in downswing, so they're more in that much more almost the earlier release phase. Again, loosely speaking, the club's been released, the wrists are moving into that more alternate deviated kind of condition much earlier in that downswing phase. Equally so then, we look again, as shown by the circle on the screen, their peak hand speed, the angular velocity of that speed, has happened much earlier than the advanced player, 34.4 milliseconds in advance of impact. And then once again, as shown by the circle on the screen, the peak hand speed being produced is 1,341 degrees per second. So a very, very different interaction timing of, for example, in the recreational player, no stretch in that three-dimensional value of that wrist in transition. A very, very different actually wrist orientation at top of backswing. The peak stretch therefore happens in transition because there is no stretch, so therefore it's happening much earlier in advance of that impact. Look at then the peak hand speed relative to the stretch being produced. The wrist is much more in its early release phase. For example, in the recreational player, so it's been released much earlier relative to then the more advanced player. The hands are peaking much earlier in that angular velocity definition relative to, once again, the advanced player. And the hands are also rotating much slower. So when we look at the idea of lag, lag is this interaction between areas such as not just how much the wrist stretches, but when it stretches relative to, for example, then impact. So the time difference between the peak wrist stretch relative to its impact position. What's also vital is then, for example, the peak stretch being produced relative to the maximum hand speed. So what's the angle being produced through three-dimensionally the wrist and the shaft relative to when the hand reaches its peak speed, and also then where is the hand peak speed relative to then its impact position. So these timings, these interactions, these wonderfully intrinsic, very intricate in some ways, connections between hand speed, timing of hand speed relative to then maximum stretch, the amount of stretch, then the amount of stretch relative to, for example, its top of backswing orientation value, are very, very influential on areas then such as club head speed, club delivery, force production, force application, force absorption, which is then hugely influential on things like kind of pain avoidance, which is vital, for example, when looking at areas such as the wrist because of the prevalence there in areas then such as kind of wrist injuries that many people are exposed to. So the idea of lag in some ways has been hugely demonized by many, like caffeine and like stress. Caffeine has tremendous efficacy from the performance, a cognition understanding. Stress is hugely valuable to allow both our bone structure, our tissues, our cognition, our brain, our learn to evolve and develop. It's when there's dosage issues, volume issues, timing issues with things like stress, caffeine, for example, that's often when it becomes problematic. So the word itself often creates stress. Often when you see the word stress, that itself then becomes stressful for some, but we need stress to evolve and adapt as a human. Very much like these ideas of lag. The lag or wrist lag is a terrible thing. It's been demonized by many. But these lags happen across every single paired connecting segment of the body, through each rib, through its vertebrae, through each joint, the foot to the ankle to the knee, so on and so on. Lag in some ways, the interaction with the club and the wrist is more than just, say, for example, how much we can kind of move that wrist more, and that is often described by some as more rate or deviation transition. It's much more connected than that. Hand speed, time to impact, hand speed relative to impact. So we're looking at lag, for example. What we need to acknowledge and consider is that much more global definition, the much bigger interaction between when those wrists move relative to, for example, how much range those wrists move through relative to their top of backswing position. When is that peak wrist stretch being, in essence, maintained, or when do they start to move into that release phase or move away from that peak rate stretch relative to their impact position? How does it then relate then to the peak hand speed? And then how does that then peak hand speed, the time of then relative to that impact position, is a much more meaningful, much more contextual definition to understand the concept of lag. So in some ways, lag itself is very helpful, despite being demonized by some. We just have to acknowledge it on a much more global, much more cohesive level to fully understand both the relevance of, the use of, and then the context of where lag fits within how the player moves and delivers the club. And to provide some additional relevance then as far as then how that really can relate to, for example, areas such as how the hands move and swing, alongside then how they interact with these lags, these stretches, then with areas such as some of the club kinetics, the club torques being produced in swing. So more to kind of give it that meaningful relevance. Where does all this then fit within, for example, contextually, how players can and may move in swing. So you'll see here we have on display two windows. This is the center of mass, force and acceleration. And in the movable plot here, you'll see this are the club couple. So the rotational force is being exposed to both around the grip and also the center of mass. So the real values of interest here, just to speed up the sequence of events, certainly with the very established, the very advanced player, the person produces those wonderful kind of lag profiles and interactions in swing. You'll see, as shown by the circle on screen, the idea of the FZ value, so the force in essence movement up and along the shaft relative then to the net force, the total net force of the X, Y, Z forces, which again is also shown by the circle on screen. So keeping those circles very valid and active now. As we move this player down, you'll then start to see, again, this is the very advanced, the very established, the recent PGA Tour winner. Now, as this player moves into impact, you'll then start to see when they get to that impact position here, that the total net force being produced is 343 newtons, whereas the actual Z contribution is 332 if we round up. So in response to all these interactions, the lags, the timings of relative to peak hand speed to impact, for example, alongside that then the interaction, the integration with the forces being produced, how much force is then being produced, the total net force around the center of mass, alongside how much of that then relates to that player's ability then to really pull that handle and elevate that handle up through impact. Again, how well they elevate the handle. When we look at the interaction more loosely, obviously allowing for the ground reaction forces and all other segment interactions. Well, this is looking more locally at the stretches, the lags in essence between the club and the wrist, and how that can then relate to, for example, then some of the kind of handle kinetics being produced. We can then see how well they're able to pull that handle up through impact in response to several frames after, for example, the interaction between, say, kinematically, how they move through club and wrist in transition. However, displaying then the less established player, the person that almost very disruptive, distracted in some ways, profiles through those wrist stretches, those lags in transition. As we move this player downwards, they then start to see very, very different values being produced as this player comes into impact. Once again, as shown by those circles on screen, we have a peak net force of 296 newtons with a much smaller ratio or proportionate contribution of 246 newtons of the Z value. So again, in response to those interactions, those lag profiles around that club and wrist in transition, how that then correlates then to, in a very kind of loose local definition, their inability in some ways to then produce those forces, how well they pull that handle up, which we know then connects in areas such as the kind of three-dimensional flat spot, the ground reaction forces, that lovely kind of bilateral interaction, the ground reaction forces connected into the handle kinetics and vice versa, alongside then kinematically how this person or how these players are then moving those profiles and those kind of lag definitions through, for example, the wrist and club. And equally, keeping this player on screen now, just going to top of backswing once again and stop again, just to speed up those sequence of events. We can then start to look at, as shown by the circle on screen, the in-plane couple, the torque being produced along that instantaneous plane of swing, which can loosely, in a very, very informal definition, in this context, again, the context of the lags, the kind of wrist movement, one could almost kind of define this as, loosely speaking, how that club is being released and delivered into impact. So as we move this player downwards now, you'll start to see when that value first becomes a minus number is really crucial as far as club delivery, force application, force production, pain avoidance, those areas in particular. So we then start to look at then that in-plane couple can be very, very influential around many of those areas. In essence, when it first becomes negative in downswing, is in essence then when the handle was almost being pulled back on to then allow that club to be released into impact. So again, keeping that circled live on screen now, you'll see almost immediately in transition, actually this frame in time now, we now have a negative value being produced in that in-plane couple. So really how early they're starting to kind of release and pull back on that handle to slow the handle down to allow that club to move in transition. So what a very early release, almost that kind of almost very overactive release in those hands. Again, that interaction between the club couples, the forces, and then those kind of lag profiles, kinematic being produced kind of through the hands, wrist and club. However, displaying once more the very established player, once again, as shown by the circle on screen, as we move this player downwards now, you'll see when that value first becomes a negative number, as we kind of take them down frame by frame, it's happened now much closer to impact. So typically in line with when we look at the research in most established, most advanced players, it becomes negative around when the hands are kind of opposite that trail side of pelvis. So again, we have these very defined interactions, the lags that happen kinematically, for example, between the hands, wrist and club in transition, alongside almost the kind of interaction then with these forces and these couples being produced in and around the club. We then start to see, for example, a much more delayed slowing of that handle in that kind of downswing phase as that club moves along its instantaneous planar swing, alongside then how well they're able to pull that handle up, apply those forces upwards, which we know then connect in areas such as then the vertical forces, the 3D flat spot, that lovely interaction between these kind of kinetic and kinematic observations. And then finally displaying the hand elevation. So you'll see in the movable pop-up window, in essence, that's the hand up and down value. So how much the hands elevate and move downwards. A U value would then define the hands are moving up relative to their start position. A D value would mean the hands have then moved down, they've moved lower then relative to their start position. So once again, just to speed up the sequence of events, we go to top of backswing stop. We have the hands elevated just under 91 centimeters upwards relative to their start position. So again, we start looking then almost kinematic, the segment positions in response to the lags, the interactions between the wrist, the hands and the club, how it fits with kind of lag to impact, max lag relative to hand speed relative to impact, club couples, then the forces around that center of mass, all these lovely interactions. We then start to see how that then displays and influences and relates to then, for example, the hand low point being produced in that downswing phase. We move this player downwards now, you'll then start to see that in the very, very advanced players, we move them downwards, they actually then produce a low value of, as we start to come into impact here, where the hands are actually now just about kind of 1.6 centimeters lower downwards in that kind of delivery phase. It is shown by really the position in space as illustrated by the animation on the screen relative to their start position. So the hands actually produce a lower value at this point in time relative to their address position. However, displaying on screen now again the more kind of recreational occasional player, top of batsman and stop, we look at the kind of hand elevations. Ironically in this one, actually a lot lower as far as the kind of the height of the elevation of the hands in backswing, but with more kind of loosely speaking kind of wrist stretch. A very, very different kind of hand position and wrist orientation profile, more stretch in the wrist, but a much kind of lower hand position. However, when we move this player downwards, in response to, again, those profiles, the interactions, the kind of lags being produced through that wrist, club, hand in transition, alongside the force along that kind of Z-axis, alongside the torques, the couples around, then the instantaneous planar swing. We'd move this player downwards now. The net response in some ways is then how that then relates to then the segment position of the hand in this case, that as we move them downwards, you'll now see that the lowest point the hands produce in the downswing relative to their start position is a value of around about, you'll see here, kind of 1.952 centimeters downwards. Then the hands start to elevate as they move into impact. So a very, very different hand profile, that how much higher the low point of the hands in the downswing is actually never lower than their address position. So the low point produced of the hand position, the hand up and down movement in the downswing, is actually never lower than its start position. So a very, very different kind of idea of the hands moving downwards, the low point, the pressure into the shaft, the force down on the shaft is very, very different in that kind of hand position, in the kind of very kind of occasional player, recreational player, the different profiles being displayed in those kind of lag movements, compared to the much more advanced established play produces that low point in the hands is actually lower than its address position in that kind of delivery phase. So these lovely interactions between the wrist profiles, the lags as they're informally called, how it relates to the hand speed, hand to impact, for example, then the in-plane couples, the z-axis forces, the hand low points. When we look at lag as a definition, it's a much more global discussion than simply saying lag is good, lag is unhelpful. Even good and bad are very hard to define. For me, it's much more, does it help or not help? Where does it fit within the relevance, the context of the question? Does having an increase in lag help? Does having a reduction in lag help? So that always then fits contextually within, in essence, what is the player trying to produce? What's that player trying to achieve? And in some ways, also, what's that player equally then also trying to avoid and move away from?